Welcome everybody. I'm Gianni Della Vittoria. I use Csound for composing. If you were at the concert yesterday night here at the theater, my piece Glitch and Spikes was premiered, and it was all done in Csound, everything. Even the construction, the mixing, the effects, the sounds, everything is done in Csound. It obviously is an homage to the meeting, but it was even an experiment for what I'm going to present. One of the most obvious issues when approaching Csound for composing music is to create a score that can be easily readable. So the experiment for that piece was creating everything with simple instruments in Csound. If you listen to the piece, it resembled some granular synthesis, but it wasn't granular synthesis, where only small bits of sounds generated and manipulated through the score, the important score, because you can create levels, different levels of organization with the sole use of the sound in this manner, for example. And obviously with the score itself, where I manipulated the phrases, the musical phrases. So the tools to make, to build a score are obviously of different nature. There are many tools, appreciable, very fantastic, like I cited just the True Blue by Stephen E. Probably you all know, but it's timeline where you can put over not only single events, but events that generate nested events. So it's very fantastic for this and other aspects. And Athena CL by Christopher Ariza, it is a command line approach, a different approach, but that produces sort of controlled series of events with the possibility to manage different parameters in a very interesting way. There are many others, but sheet music is what I focus on for this. The most obvious, probably, the most obvious approach to composing music starting from a musical score is by MIDI. You can create a score with musical software programming, an editing software program like MuseScore, Finale, Sibelius. Extract the MIDI, and Csound is able to perfectly read it with no problem. This process is fast and easy, but I wanted something more. I want the possibility to manage the envelope from the score. I don't know the noises from where.
Sounds like it's a phone, actually. Maybe it is your phone.
Oh, yeah. Okay. Just for the time.
Yeah, I wrote it.
Okay. In this manner, we can. It's quite difficult. It's not possible. According to me, it's quite difficult to describe envelope parameters in a score from which we then extract the MIDI. So even if you can do this, how can to transfer them in real time to Csound given the fact that Csound, when makes a line of code, a line parameter, needs to know the last value. How can it recognize it? How can it manipulate it? Due to the fact that Csound has to know it in advance. It's not so simple to solve this problem. So I had a look at some other tools. You probably know the Lillipond project. The Lillipond project is Lillipond is a music programming engraver that requires an ASCII tag notation inputting. It's not like Finale or Sibelius. You have to program it. It's a real language, programming language. You have to code it, and it compiles into beautiful PDFs or other formats, PostScripts, etc. There are external tools that helps inputting, like Frescobaldi. It's a very good project. Genemo, it's another good project. Genemo is similar, for some aspect, to the classical score editor, but produces Lillipond code, and Canoris, and many others. Abjad, I don't know if you know this project, is an extensive Python library that wraps Lillipond. So it's, according to me, it's fantastic because nearly every element in Lillipond is manageable through a class structure, and this is a lot better than manipulating the text Lillipond needs, because with these classes we can have a very dynamic way to manipulate and do algorithmic composition. So Abjad and Lillipond together have the ability to produce very complex graphics. So it is particularly appreciated by music composer for contemporary music, because music is quite complex for the graphics it needs. For example, this example you can see from the site of Abjad. This is a composition made totally in Abjad and rendered it in Lillipond. As you can see, probably there are many non-traditional graphics, so it's the part where that interesting me a lot. This is another composition. Take a look, for example, at this light part. It sounds, it looks like a sort of an envelope. So the idea is put it together with Csound. The authors, I'm not one of the authors of the project Abjad, but the authors declare that the project is not aimed to sound, it's aimed only to engraving, to printing music, but it's an aspect I like as a Csounder, as I like, because there is a richness of possibilities that we can use as much as we like. The problem is to make choices, because we have too many possibilities. Which is the better choice? One idea is this. My proposed workflow could be this. Create a Csound orchestra. Create a Lillipond score with Abjad. Translate it into a Csound score. activate Csound through the Csound, the beautiful Csound API controller module, all in Python. And we can take a look at an example. This is a simple beginning of score with 5 instruments. These are 5, we can think of it as 5 synthesizers that are written in score music, normally score music. How can we attach them to Csound? Each Csound instrument has a dedicated stuff. We are free, this is my proposal. We want to extract the onset, duration, and pitch information for the Abjad parser could give Csound the necessary information. For the reason I told about a few minutes ago, I don't like to use the MIDI, but the MIDI interface is present in Lillipond. So if you are okay with MIDI, you can use the MIDI aspect. But I can't work with my ideas, so I prefer this approach. But it's very simple, because this is the part of code, the main part of code necessary to do all this. This is a parser we can read in the first line, if you know Python. For logical tie in Abjad terms is the iteration over single notes, but more notes tied together are counted once, only once. And that is exactly what we know, what we want. Because we in Csound are used to reason in terms of seconds. Here we can think of the music in terms of musical figures of duration. So the iteration is on logical ties, pitched through equals through, because we want to avoid rests. And we need 3 information. The offset is the offset or the onset time for Csound, the PQ, the second parameter of the typical score of Csound, is provided by the time span start offset class. This offers a duration, a point in time, an absolute point in time, expressed in musical figures from the beginning. So we need to convert it in second, and the second line represents the conversion. Same thing for duration, the P3 Csound. And we create the list of strings. The last part, the last line, represents the conversion of pitch. Pitch is given by Abjad in these terms. 0 equals C, the middle C. 1 C sharp, 2 D, etc. So if we add 60, we have the MIDI number, the MIDI corresponding. The CPS MIDI in opcode in Csound is able to interpret the chord notation. So it's all. We can even use microtonal tuning with no limit. And the envelopes. How can I realize envelopes? The envelopes could be envelopes drawn directly on the score helps readability for me is important because when I composed that piece, I had to be aware by memory what I've done in other lines, because there were a long series of numbers. So here we can see the various parts of the envelopes of the parameters. So the last line, this is on a representation of graphic envelopes. But there are many possibilities. The first, with traditional music markings. It's good, readable, but synthesizers are capable of a lot more. So we can use postscript, but postscript like this. Beautiful, represented, like famous synthesizer, but we don't know exactly when reading, we don't know exactly the time position of the vertices of the envelopes. We could know only if the representation was proportional, but music of this kind, according to me, it's possible to represent proportional spacing in this kind of engraving, but I would prefer the normal representation of music, not proportional, because I can represent a whole note and a series of quick notes, sixteenths, one next to the others, without having to take too much room. So my idea is not all of that. Let's represent envelopes only by simple staves. It's probably the fastest way. Managing notes is the most natural thing in Abjad. It allows for easy algorithmic manipulation, like even another instrument. So let's examine a simple example. We may do this orchestra. This is a complete orchestra, simple orchestra. The first instrument is an FM made by Fossili, which has the K and DX as a unique parameter manipulated in the way I will show. The other are fixed numbers for now. The second is the Linseg instrument Lin, second last part, where I have put on very long befielded Linseg, because I don't know in advance how many vertices the envelopes will have. So this is my orchestra. Now we want to infer the vertices of the envelope for the Linseg. We must establish the range for each parameter, as it's an index modulation for an FM, a frequency modulation. I arranged it from 0 equals to middle C, and 20 to C tri-octave higher. So 2 octave, 24 semitones divides the range of this envelope. The Lin instrument has a very long field, and each FM instance is activated simultaneously with its Lin instrument. So the game is, I activate the FM instrument, I activate the Lin instrument. They are given a unique channel number that I write on a table that I update, so we don't risk any overlapping on an interference between overlapping notes, and it's done. The score starts like this. but the score is inferred by the notes. For the part of the envelope, we have this part of code that is similar to the one we saw before. But we have to filter a window time, a time window in which to individuate the correct envelope, because the envelope can have as many vertices as I like. So the channel represents this mechanism of no superposition for overlapping notes, and the score is here. So this is a typical approach. This part is the part where I input the notes for the vertices of the envelope, the upper staff, while the lower staff represent the notes transformed in frequency. So this is the idea. This is just an example, a very little example, with this instrument and with a very, very little code, because the code is like this and replied in loop with different duration. Just a little, I probably... Just to give you an idea. The loop has a different envelope now. Just another example. This is to demonstrate polyphony. So the code was that, and now this last example is with more parameters, the three parameters of the first is the amplitude, the second the modulation index, the modulator, the frequency of the modulator, and the third is the index modulation, the modulation index. And the interesting part is that I have the number represent only to demonstrate the actual parameter, the actual value in real time, and it can be used to module the interpretation of simple music like this. It's the same instrument. And just to show you, if you don't like the presentation of envelopes with notes, with pitched notes, you could use other system like this, because graphics doesn't lack anything. Something like this for exponential glissati, and something like this probably demonstrate how you can with total freedom represent your own sound. And the great thing I think of this approach is that you decide what you want and as you want it interpreted by Csound. And it's very simple. Thanks, that's all.